In this video, we'll go over some key terms on expressions, and then we'll talk mainly about the distributive property. First off, an algebraic expression is an expression that contains at least one variable. Okay, and a variable is just some unknown number. Let's call it x. So right there, x, that is an algebraic expression. It has at least one variable. Now, expressions can also have operation symbols like the plus sign or the minus sign. So we could have something like x plus 5. Right? This is an algebraic expression. It has a variable x, has an operation symbol plus 5. Okay? Now, in this expression, there are two what we call terms. X is a term, and 5 is a term. This is actually positive 5. That's what the plus means. This is positive 5. If we had x minus 5, there would still be two terms, and the terms would be x and negative 5. And so the negative right there functions as a negative sign or as a minus sign. Okay? So there's two terms. X minus 5, 1, 2. So let's say we had something like 9x plus 5. Let's say we had 9x plus 5. There's still two terms. One term is 9x. The second term is positive 5. The 9, we would call this 9 right here the coefficient. The coefficient is essentially the number in front of the letter. It's a number in front of the variable. So 9x means 9 times x. We would read this expression as 9 times x plus 5, where 9 is the coefficient. 5 would be what we call a constant term. A constant term is a number with no variable, right? So the constant here would be plus 5. If it was 9x minus 5, the constant would be negative 5. Again, the minus sign functions as a negative sign or as a minus sign. Okay? Now, I'm going to do on your 6.1 packet, 6.1 page 1, I'm going to do number 13. Okay, number 13 has you using the distributive property. You have 10 times 9x plus 5, and you need to distribute. So here we have a number times an expression. To distribute the 10, you multiply 10 times all the terms inside the parentheses. So you do 10 times 9x, 10 times 9x, and then you put plus 10 because you're distributing a positive 10. Plus 10 times 5. Okay, now if I simplify this, 10 times 9x is 90x, plus 10 times 5 is 50. Okay, so this would be my answer once I distribute, 90x plus 50. Okay, now let's say I had something like this. This one's not on your packet, but let's say I had 10 times 9x plus 5 plus 2x. Now here, to simplify this expression, I would still need to distribute, like I just did. Distribute the 10 to the 9x and the 5. I only distribute to the terms inside the parentheses. Here, I would not distribute the 10 to the 2x because this 2x is not inside the parentheses. So I distribute, I still get 90x plus 50, and then I add this term on, plus 2x. Okay, so now this is my expression. Now I need to combine like terms. Like terms. Like terms are terms that have the same variable, so they have to have the same letter. They have to have same variable and same exponent. Same variable, same exponent. Remember, when the exponent is not written, the exponent is 1. So here, 90x and 2x are like terms. I'm going to put boxes around them to show that they are like. They're like terms. They have the same variable x and the same exponent, 1. 90x, 2x. Now notice that the coefficients can be different. The coefficient here is 90. The coefficient there is 2. The coefficients can be different. The only thing that needs to be the same is the variable and the exponent. Okay? So I'm going to combine these like terms. Combine means add. So I'm going to add 90 plus 2x. 90 plus 2x is 92x. Notice here when I put the shape around this, I included the sign. That's very important that you do that. it's very important that you include the sign inside the shape. So 90 plus 2x is 92x, and then I add this term, 50. Okay, so this would be the simplified expression if I had that expression. Okay, I'm going to do one more like that. Let's say I had something like 10 times 9x plus 5 minus 40. Okay, just like we've been doing, I'm going to distribute the number in front of the parentheses. So I'm going to distribute the 10 to the 9x and the 5. So I get 10 times 9x is 90x. 10 times 5 is positive 50. And then again, I add this term on. So here are my like terms. My like terms would be the constants, the constant 50 and the constant negative 40. Okay, so I need to combine those terms. I still have 90x, and then I have positive 50 minus 40. 50 minus 40 is 10. I put plus 10 for positive 10. So this would be my simplified expression. Okay, again, those are me combining the like terms, which have the same variable and the same exponent. Okay, the last example I'm going to do is one factoring example. Okay, this is number 10 on the 6.1 packet, page number 1. Okay, so here I am given 90x plus 50, and I need to factor this. Now, factoring is essentially reverse distributing. Whenever you factor something, you need to write this expression as a product. Okay, now as you can already tell, this is what we got when we distributed up here. So our answer is going to be this, what we started with, 10 times 9x plus 5. But let's see how we get there. To factor this expression, I need to look for a factor that goes into both of the terms, that goes into both 90x and 50. Essentially, you're looking for the greatest common factor, the greatest factor that goes into both 90x and 50. That greatest factor is 10. 10 goes into 90x 9 times, and I have to include the variable with it, right? Because once I multiply these numbers, I should end up with 90x. So 10 times 9x would be 90x. Okay? And then 10 times what number is going to give you 50? Well, 10 goes into 50 5 times. Okay? So 90x plus 50, if I factor that, I get 10 times 9x plus 5.